Hello and welcome you all. Today we are going to solve a very interesting problem. The problem is based on the steady flow energy equation. We are going to solve with the help of the software. The objective to solve the question from the software is very simple: to demonstrate the use of the software first, and second is you can visualize better with the help of software, because you can easily change your parameters and you can see the effects of changes in the output, especially the Matlab software we are going to use. So you will get some feel how you can approach the advanced problem with the help of Matlab software. Okay, so let's directly jump into the question and see how we can solve this problem. So this problem is based on the steady flow energy equation. There is one turbine. So first I will read the problem. There is steam flow steadily through an adiabatic turbine. The turbine is the adiabatic. So let's suppose this is the turbine, this is the turbine, and this is the adiabatic turbine. The inlet condition of the steam are 4 megapascal. That is, the inlet condition is the 4 megapascal. Let's suppose this P1 is 4 megapascal is given, and the temperature is, this is the degree, 500 degrees Celsius. Temperature is 500 degrees Celsius. Temperature is 500 degrees Celsius, and velocity is 80 meter per second. Velocity 80 meter per second. Velocity 80 meter per second. What is the exit condition? Exit condition is P2 30 kilopascal, and 92% is the quality. The quality means the dryness fraction. Since the steam will be in the phase change zone, let's suppose the dryness fraction X, and it is given as 0.92, and velocity is 50 meter per second. Now the mass flow rate they have given m 12 kg per second. Now they are asking about the change in kinetic energy, which is very simple to calculate. The change in kinetic energy will be delta Ke will be V1 square minus V2 square upon 2. This will be the change in the kinetic energy. Second question, they are saying what is the power output. So for that you need to write the equation, steady flow energy equation. Steady flow energy equation is energy at the inlet is equal to energy at the outlet. What are the energy at the inlet? Let's suppose that is the enthalpy at the inlet, and heat is supplying, but the turbine is insulated, so we will take 0, and is equal to plus kinetic energy is equal to energy at the outlet, which consists of enthalpy and work and kinetic energy at the outlet. So this is simple, because the turbine is insulated, so we are taking Q is equal to 0, Q0. So the equation will be H1 plus V1 square upon 2 is equal to H2 plus W and plus V2 square upon 2. So W will be H1 minus H2 plus V1 square minus V2 square upon 2. This will be in the kilojoule per kg. So you need to multiply with mass flow rate to calculate in the kilojoule per second. So if you multiply the mass flow rate, then result will give in the kilojoule per second. So that's how you can calculate that power output. But to calculate the power output, you need to calculate the enthalpy. For that they have given that inlet pressure and temperature. So H1 is the function of pressure and temperature in the superheated zone. So if you are doing the hand calculation, then you need to know how to read the steam table. From the steam table, in the superheated steam table, what you will do, at given pressure and temperature, you will see the enthalpy value and just write that enthalpy value here. Just put it here. Similarly, H2 is in the phase change zone, and you need to know the two property, one the properties are given 30 kilopascal and 92% quality. So here is the 30 kilopascal means pressure is given, this is P1, T1 and X is given. So from here you will calculate the H2. Calculation of the H2 is very easy in hand calculation also. You need to know the steam table, you need to go the saturated table. In the saturated table you will see where is the 30 kilopascal. In the 30 kilopascal what you will do, you will calculate, you will see the HF and Hg value. What is HF? HF is the enthalpy at the saturated liquid and Hg as the enthalpy at the saturated vapor at the 30 kilopascal. And what we will do, just you can calculate very easily, H is equal to HF plus X into Hg minus HF. We will directly implement this code, this much code in the software, in the Matlab software, and we will use a function to calculate the H1 and H2. I will show you the code, don't worry. What is the next question? Next question is, so first question is solved. I will show you how to solve this question. I will show the code also. The second question is find the effect of the variation of exit pressure. Means here the exit pressure is 30 kilopascal. Now the second question is saying that you have to vary that pressure 10 kilopascal to 200 kilopascal and see the effect at the power output. Okay, so to solve this question you need to take the help of software, because they are saying that vary the parameter, and variation of the parameter is not very easy all the time in the hand calculation. So you need to take the help of the software. You need to vary this pressure from 10 kilopascal to 200 kilopascal and plot what is the variation of the power output. So from this question you will get the idea also, if the exit pressure is increasing, how the work done or power output is decreasing or increasing. So we will see that. Okay, so this is the objective also, to solve this problem from the software. So let's directly jump into that. So this is the Matlab code for the first problem. I will explain line by line. So this is the mass flow rate, m dot. Mass flow rate is given. This is the pressure. Pressure is in bar. So this is the 4 megapascal. That's why I am taking 40 bar. 4 megapascal is equal to 40 bar. This is the temperature. Temperature is in degrees Celsius. P2 is in bar. P2 is the 30 kilopascal. 30 kilopascal is equal to 0.3 bar. Why I am taking the bar? Because the function is designed in such a way. I will explain you, don't worry. So this is the X. X is 0.92. This is a dryness fraction. And this is the velocity at the inlet and velocity at the exit. So this is the function. This is the function. What is the name of the function? XSteam. So I will share you with a link. From that link you can download this function file and you can save in your folder. So from there you can access this function file. Okay, this is the function. Basically it acts like the steam table. So what you need to give, you need to give that input parameters and you will get the desired output. So for example, this is the function XSteam. What you need to calculate? You need to calculate the H, means enthalpy. What are the input parameters? Pressure and temperature. What is the value of input parameters? P1 and T1. So as I explained, H1 is the function of P1 and T1. So in this way you have to implement that code to calculate the H1. Secondly, you need to calculate the specific volume. So for a specific volume, simply what you will get, this is the function, and what are the input parameters, pressure and temperature, what are the values, P1 and T1 is the values, and from that you will get the V1 also. Similarly, H2, for the H2 you need to specify the value of X and pressure. Okay, so reason is very simple. If this is the expansion, then let's suppose this is the 2 points, and here is the dryness fraction line 0.92, X is equal to 0.92, and this is the pressure. So two properties are needed to calculate the state at the phase change zone. So you need to calculate the pressure and dryness fraction. In the saturated zone, from the pressure and temperature you cannot fix the state of the system. You need to either you need to know the pressure or dryness fraction or pressure or specific volume. From that you can calculate, you can fix the state of the system. So here you need to calculate the enthalpy H, pressure and dryness fraction is the input. What are the value of the pressure? Pressure value is 0.3 bar and dryness fraction value is 0.92 bar. The same function you can calculate the specific volume also. How you can calculate the specific volume? You can calculate the specific volume with the help of pressure and enthalpy. So enthalpy you previously calculated. So from here, this is the pressure 0.30, and what is the enthalpy? H2. So from here you can calculate that, specific volume at the outlet. What is the turbine inlet area? How you can calculate turbine inlet area? M is equal to rho or A1 V1 upon specific volume nu1. So you know that what is the value of specific volume, you know that what is the velocity at the inlet, you know that what is the flow rate. From here you can calculate the area at the inlet. M is equal A1 is equal to M dot nu1 upon V1. That same code is applied in the Matlab. A1 is equal to M into V1 upon nu1. Change in kinetic energy, 0.5 V1 square minus V2 square upon 1000. Why we do upon 1000? To convert that in the kilojoule per kg. So that will give in the kilojoule per kg. Power output is simply H1 minus H2 minus change in kinetic energy. So H1 is equal to H1 plus V1 square upon 2 is equal to H2 plus V2 square upon 2 plus W. So H1 minus H2, and this will give the change in kinetic energy. Delta Ke is equal to W. That will give basically the work done in kilojoule per kg. When you multiply with that mass flow rate, then you will get the power output. So this is the code for the problem number 1. How you can solve, how you can modify this code in the more generalized way so that you can solve the problem number 2. So let's jump into the problem into 2 in the Matlab code. So similarly, in all the inputs are same. Here is the difference. What is the difference? You need to vary the pressure from 10 kilopascal to 200 kilopascal. So in the Matlab there is one function that is a linspace. What linspace is doing? It distribute the two values at equal number of points. So the pressure is 0.1 bar and pressure is 2 bar. That means 10 kilopascal and 200 kilopascal. And what linspace is doing? It distribute it in 20 points. So suppose this is the 0.1 bar and this is the 2 bar. So linspace is dividing it in 20 points. So you can take the 40 points also. then it will divide in the 40 points. Okay, the more number of points, the better the plot will be. This is the dryness fraction, similar to the previous question. This is the velocity at the inlet, this is the velocity at the outlet. Similarly, you can calculate that H1 and V1. H1 and V1 is similar, but for H2, because the pressure is changing at the exit, the pressure is changing, H2 will also change, and you need to store all the value of H2. Okay, so what you have to do, you have to implement the for loop, and you should store all the value. There is 20 values of H2, because you will divide the pressure in the 20 different equal values. You know that from 0.1 to 2 bar you have 20 parts. So for that, what you need to do, you need to store all the values of H2. So H21 means first value of H2. H21 is the first value of what will be this is 0.1 bar. Similarly, H220, what will be the value? 0.02 bar. H22, what will be the value? 0.2 bar, like that. So each and every value of H2 at different pressure you are storing here. So when I is equal to 1, H21, when I is equal to 2, H22, when I is equal to 3, H23, when I is equal to 4, H24, and these all values are stored in the form of array of H2. This is the array of H2. Here H21, H22, H23, H24, H25, H26, like that, H220, up to H220, these values are storing. Similarly, V2 also, you are storing the value of V2 also. So V21, V22, V23, V24, V25, V26, these kinds of values are storing in the array of V2. Now what you are doing, you are similarly calculating the A1, and similarly you are calculating the kinetic energy also, change in the kinetic energy also, because V1 or V2 are not changing. V1 and V2 are not changing. V1 and V2 are the constants. What are changing? What is changing? Only pressure is changing. So how you calculate the power output? Power output is also different, because the pressure is different. First P1 is the P2 is the P21 is the 0.1 bar, P22 is the 0.2 bar. So power is also different. Now what is happening here? I am storing the W at different position in the array 1, 2, 3, 4, like that, 5, with respect to different pressure. 1, 2, this is the pressure at the exit P2, and now I am plotting that work corresponding to the exit pressure, and this is the plot. This will be the plot. So now from here what you can see, as you are increasing the pressure, the work done, your work output is decreasing exponentially. So initially the pressure, when the pressure is low, when the exit pressure is low, this pressure is in bar, so as you are increasing the pressure, the work done decreasing. So initially the work done slope is low, and then slope is increasing. Initially the slope is low, and then slope is increasing. So as you increase the pressure, power output continuously decreasing. Okay, so this is the conclusion, and this is the question solution with the help of the Matlab software.